Okay, so we can graph the logarithm. Now, looking back at 2 to the x, right? What did we say inverses are symmetrical around what line? Remember? What's this line right here? I'm trying to draw it like really accurately. Can anyone tell me the equation of that line? Y equals x. What's the slope? 1. What's the y-intercept? 0. And so what the logarithm does, the logarithm is the inverse of the exponential. And remember what we were talking about when I wanted to graph an inverse, what did I have to do with the x's and y's? Swap them. So this point becomes 0, 1 becomes 1, 0. Okay? This point it was 1, 2 is going to become 2, 1. This point, which was 2, 4, if you swap the x's and y's, what does it become? 4, 2. You're actually starting to see the inverse emerge, but let's go back to the graph and we'll actually graph it for real. Okay, so because this is saying the base was 2 of the number, if I want to create a table of values, x, y, really what I want is I want numbers that I actually want the y to be the exponent. What this is equal to is the exponent, right? So if I use my y values as the exponent, thinking about how 2 to the y equals x is the same thing using the definition of logarithms. If I use the exponent -2, -1, 0, 1, 2, it actually goes backwards because it's the inverse, right? So 2 to the -2 power is 1/4. 2 to the -1 power is 1/2. What's 2 to the 0 power? 2 to the first power, 2. 2 to the second power, 4. 2 to the third power, 8. So our x values actually become a little bit, usually we plug in values of x, but because it's easier to say, well, the y is the exponent since it's the opposite of the 2 to the x. Here, we'll just plot these points then. 1/4 is really close to 0. 1/4 -2. So that's 1/4 -2. 1/2 -1. So 1/2 -1 is here. And then 1, 0. Now we have an x-intercept. 1, 0 is the inverse of the other point, which was 0, 1, which was the y-intercept. 2, 1, go over 2, up 1, 4, 2, and the exponent for 8, 8, 3, right? Because the y value now is the exponent, so 8, 3 is here. So you can see this is the inverse, this is the logarithmic function here. Now, we can also use our graphing calculator to graph this as well. So if I go to y equals, I want to press clear. I want to clear everything out. I probably want to zoom. I'm going to zoom it in after this, okay? But if I want to type this in, some of your calculators, you only actually have 2 buttons that say log. But how many different bases could you have? You could have an infinite number of bases, couldn't you? Because you can take any number to a power. So that gives you an infinite number of bases. Turns out that this base is 10 and this base is e, which is the inverse of the exponent, right? Or the e to the x, the exponential function. So some of your calculators have math, a math button. And then if you scroll down, you should be able to see a place where it says log base. Not every calculator has this log base, but this allows me to change the base to 2 and enter the variable x. So now if I graph this, and of course I didn't change my window, so let me go back to the original viewing window by going zoom, standard. Okay, so there's my log base 2. If your calculator does not have the option to put in any log base, you still can do it, okay? You would just have to do a change of base, which we haven't quite learned yet. But if you were going to enter that in on your calculator and you didn't have that change of base, you would go log of x divided by log of 2. Okay, that's what you would enter in on your calculator. So I'll just show you. And it's going to be cool because it's going to trace over that one. So that one was in orange. I'm going to trace it over, and if I go next, I'll trace it over in red. So I would enter it as log of x, close the parentheses, divided by log of 2. And how do I remember that? Is because I think, well, the base has to go in the bottom. The base goes in the bottom. The base was 2. These logs right here are default log base 10. That's probably to do with the fact that our number system is base 10, right? Our counting system. So now if I graph this, there's the orange one. You see how the red line is tracing over it? It's literally the exact same thing. So that's the way you would enter it if you have no log base selection in your math menu. And then we can see the table of values. If I go second table, I'm not going to see these fractions because on my table, it's not going to show that I have any fractions because I didn't set it up to count by fractions. So look what happens with 0. What do we get when we type in x equals 0? We get an error. This is because, think about this for a minute. Can you take 2 to a power and get a negative answer? Can you give me any exponent for 2 that's going to result in a negative number? The answer is no. There's no such exponent where if you plug in that number, you're going to get a negative. So that's why here I'm not going to have any negatives for my x values because remember, these are all the y values here are all the exponents. There's no exponent that I can give to 2 that's going to result in a negative. Okay, so let's answer some of these questions here. What's the y-intercept? There's no y-intercept. And that's because, again, can you take 2 to any power and result in 0? There's no such number. Okay, what about the x-intercept? Now you have one, right? And what was it? 1, 0. That's because before you had a y-intercept, remember this is the inverse, so it's the opposite. Well, not really the opposite, it's the inverse, so the x and y's swap. Okay, state any asymptotes. Do you see any asymptotes happening? X equals 0, and that's our y-axis. So this is our asymptote because we're getting really, really close to 0, but we're not touching it. What's the domain this time? What values of x can we use? 0 to infinity, and that's where you see that asymptote again happening. Okay, and what's the range? Negative infinity to positive infinity. Again, the inverse, so all the x and y's swap, which means the domain and the range swaps. So the graph of a logarithmic function is always going to have these characteristics, okay? The basic logarithmic function. So log base b of x will have an x-intercept. We saw that happen at 1, 0. The graph approaches but does not touch the y-axis. Therefore, that creates a vertical asymptote, which is x equals 0. Is the graph a one-to-one function? Would you say it is? Yes, it is. Okay. And what about the domain? The domain is from 0 to infinity because of our vertical asymptote. And then the range is from negative infinity to positive infinity, because you can see the arrow going down and the arrow going up in either direction. Any questions about that?